Certain hints or keep in mind notes were provided to our viewers and students regarding the topic electrochemistry, and it should serve as a ready reckoner or hints or point to be kept in mind. And the topic which we had provided were electrochemical cells, electrolytic cells, and also conductivity. I consider it worthwhile to take up now the practice questions on a topic one by one. And today we have chosen a topic for practice questions is ionic conductance in solutions. Now, therefore, let us take up the first question. The first question is, which of the following is a specific conductivity reagent? We use certain ionic compounds, particularly potassium chloride, as a conductivity reagent for determining the specific conductivity. And therefore, we must know what is the specific conductivity. The specific conductivity or conductivity of an electrolyte solution at a given concentration is the conductance of 1 unit volume of a solution kept between two platinum electrodes with the unit area of cross section and at a distance of unit length. That the area should also be unity and the length should be distance between the two electrodes should also be equal. Now let us take up the next question. And the other question is, of course, very simple, and it is here. The equivalent conductance of 0.1 and sulfuric acid offering a resistance of 50 ohms when placed in a conductivity cell whose electrodes are 1 centimeter apart with a cross-sectional area of 2 square centimeter at 25 degrees Celsius is. Now, this calls for certain calculations, and a simple expression has to be used here, that conductivity kappa is equal to conductance into cell constant. And we know conductance is nothing but the inverse of resistance. So cell constant is length upon area. Now whatever values are given here, we substitute these values and we get the answer as 100 Siemens centimeter square equivalent inverse. And therefore our correct answer is option 1 or A. Other options are not applicable over here. Now, one thing I must tell you regarding this question, that the equivalent conductance, so far as equivalent conductance is concerned, we have to use this relation. Kappa is equal to 1000 upon concentration of the solution at equivalent or normal concentration using equivalent weight, that is normality. And when you substitute the values properly, you get the answer. Okay, now let us proceed to the other question. Then the question is, choose the correct order of molar ionic conductivities of the following ions. And 4 options are given as usual. We find that the ions which are provided over here in all the options are the elements of group 1 element, S block element, that is lithium, sodium, potassium, and rubidium, which are all unipositive. And we have to pay little attention to the options given over here. We find that according to the options A, B, C, and D, in each option it is provided that lithium has the minimum ionic conductivity, whereas other ions might have higher ionic conductivity. Well, if you recall and consider a little, we will find that the ionic conductivity depends upon the size of the ion. An ion which is smaller in size should have higher conductivity as compared to an ion having greater size. Now here we find that it is just lithium, which is a smaller ion, the smallest ion I would say, unipositive, the smallest ion, that is shown as a minimum conductivity, least conductivity here. So we have to pay a little attention why this happens. And it happens because what happens that when you prepare a solution in liquid state, solution of lithium or sodium, potassium, rubidium, the lithium gets hydrated. And when the hydrated lithium ion is there, the size of the hydrated lithium ion is slightly bigger than even rubidium. And therefore, the lithium has minimum conductivity as compared to other elements or other ions provided over here. And that's why we can confidently take up that our option A is correct. The reason being these explanations which I have given to you and are provided over here. A hint. Next question. Now let us move to the next question. The next question is, of course, very important, that lambda m for sodium chloride, HCl, sodium acetate are given here in Siemens centimeter square mole inverse respectively. And we are required to calculate the lambda at infinite dilution for acetic acid. HOAC means acetic acid. And the values are given here. Naturally, therefore, it calls again for certain calculations using what is known as Kohlrausch law. Kohlrausch law, according to Kohlrausch law, the equivalent conductivity of an electrolyte at infinite dilution, that is zero concentration, is equal to the sum. Of course, it's wrongly typed here. It should be SUM, that is addition, sum of the conductance of anions and cations. If salt is dissolved in water, the conductivity of the solution is the sum of the conductance of the anions and the cations. And these lambda m, the conductance at infinite dilution or zero concentration, is given here. Accordingly, we must perform certain calculations which can be called as algebraic calculations. We will have to write the ionization equation for acetic acid, and acetic acid is containing acetate ion and hydrogen ion. So the molar conductivity of acetic acid will be lambda at infinite dilution H plus acetate ion. And accordingly, we have to write the ionic concentrations, ionization of different ions here, and we need to just consider about that how we can get this equation by adding the conductivities or subtracting the conductivities which are provided over here. Accordingly, you find that this would be the correct calculation so far as determining the conductivity of acetic acid is concerned. Now, we know that HCl ionizes to H plus and Cl minus at infinite dilution, that is molar conductivity at zero concentration for HCl, molar conductivity at zero concentration for sodium acetate, and similarly for sodium chloride. So this algebraic calculation where particular ions are subtracted and a certain number of ions are added gives you the relation so far as the um, uh, desired expression is concerned. Then put up the values here and you get the correct answer as 390.5 Siemens centimeter square mole inverse. So definitely now, as per calculations, we can say that option 1 is correct. Now other options are not applicable over here. Next we move to the next question, and the question is, of course, very straightforward. The conductivity of centimolar solution of KCl is 25 degrees Celsius is given as 0.0210 ohm inverse centimeter inverse, and the resistance is given as 60 ohms. We need to calculate the self constant. The question is very straightforward, and it has to be calculated using relation conductivity kappa is equal to conductance, that is G into cell constant G star. And G, as we know, is inverse of resistance. Put up the values to get the answer 1.26 centimeter inverse. So that's the correct answer. And it has been a neat question, quite important and as well as simple also here. Next question we have to take up is here, and the question is about assertion reason type question. Now, as usual, there are two statements provided. One is known as assertion A and the other is known as reason R. We have to just consider carefully about the statements provided here for assertion as well as for reason. Assertion is delta G is equal to minus NFE cell. Delta G depends on N. Okay, it's all correct. It depends upon N. And reason R is E cell, that is electrode potential of the cell is an intensive property and delta G R is an extensive property. This is also perfectly correct. So we find that assertion and reason both are correct. Now look at the options here. As we find option 1 says A is true but R is false. No, it's wrong. This option is not applicable over here because both the options are correct here. Similarly, 2 is also wrong. Third option, of course, we have to consider more carefully, and that is A and R are true, but R is correct explanation of A. No, it's not a correct explanation of A, and therefore this is also wrong, incorrect. Finally, the fourth option, but we find both assertion and reason are correct. A and R are true. That what we have established, and R is sure not a correct explanation of A. That should be the correct answer. And therefore, our answer is option 4. That is the right answer. And for you, here are certain notes provided here. Just a hint for this particular type of questions. And I suppose you must have got it. How to tackle such questions, we need a little consideration. And if you pay and go through the hints which I've already provided, probably it will find very convenient to take up several questions of this type. Okay, we stop here and we shall take up more number of questions a little later in different videos. Okay, thank you very much. Please do subscribe to our channel.